Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the applications of the auxiliary planes regarding evaluation of the true shape and size of the inclined section surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a section solid which has been cut by an auxiliary inclined plane. Now this is an inclined surface that we are left with, and we are required to evaluate the true shape and size of this particular inclined cut section surface of the solid. Now in order to evaluate the true shape of this shaded portion, that is the inclined portion that we are having, we need to develop the orthographic projections of the solid in such a way that we should be getting the edge view of this inclined section surface in one of the orthographic views over there. So we are going to draw the front view of the solid from this orientation. So when we are going to look at the solid from this orientation in the front view, so we'll find that we are able to observe this cut section in an edge view. So this inclined cut section will be available with us as an edge view in the front view once we are looking at the solid in this particular direction. And the second orthographic view we will be drawing is the top view of the solid. And then using the information available with us through these two orthographic views, that is the front view and the top view projections of the solid, we will be drawing an auxiliary inclined plane which will be parallel to this inclined section surface, and the projections of this inclined section surface onto the auxiliary plane which will be drawn parallel to the section surface will be providing us with the true shape and size of this shaded portion over here. So let us proceed with the construction of the front view projections and the top view projections of this particular solid. So the various dimensions regarding different elements of the solid, they are available with us, and using these dimensions now we are going to start with the construction of the orthographic projection. So the front view we are going to draw while looking at the solid from this orientation, and the top view of the solid will be obtained when we are going to look at the solid from above. Now regarding the front view projections, so we know that the width of the solid as it appears in the isometric projection, so this is equal to 70 millimeter, while the height of the solid, it is equal to 60 millimeter. So the front view will be a rectangular face having base or the width equal to 70 millimeter, and the height of the front view will be equal to 60 millimeter. So this is the width of the solid which we have marked as 70 millimeter. So after marking this width of the solid equal to 70 millimeter, we have drawn two vertical projector lines which are going to provide us the guideline for construction of the front view as well as the top view, because in the top view also we are going to require the width of the solid which is equal to 70 millimeter and the depth of the solid, it is equal to 60 millimeter. So for the top view construction we are going to require the information regarding the depth of the solid which happens to be 60 millimeter. So the height is 60 and the depth is also 60. Now we are going to draw this horizontal line over here at a distance of 60 millimeter from the XY reference line, and this height 60 millimeter, we can check it has got three elements. That is element number 1, this is corresponding to this web which is available at the top surface of the solid, and here the height is equal to 15 millimeter. Similarly, the bottom web of the solid, again it is having a height of 15 millimeter. So the remaining portion height will be equal to 30 millimeter. So these are the three elements that we have in the front view. Similarly, corresponding to the top view, so this is the starting point of the top view, and we know that the depth of the solid happens to be 60 millimeter. So with this depth of solid equal to 60 millimeter, we have been able to obtain the rectangular face corresponding to the top view of this solid. So having obtained the rectangular face corresponding to the front view over here and the rectangular face corresponding to the top view construction of the solid, now we are going to locate different elements of the solid within this front view face as well as the top view face over here. Now as we have discussed that in the case of this particular solid, as we are going to look from this end, so we find that the height of the solid, it is equal to 60 millimeter, while the width, it is equal to 70 millimeter. So along the width over here, we have got a rectangular surface which is appearing over here right at the top of the solid, and we know that the width of this particular rectangular portion happens to be 20 millimeter. So out of this total width of 70 millimeter, so this 20 millimeter, it is the width of the top web flat portion over there. So this is the flat portion which is occurring at the top of the solid, and only once this particular flat portion, it is going to wind up over here, it is going to finish over here, the inclination of this particular cut section will be starting over there. So from the top point, that is point number 1 and point number 2, they will be starting from this position. So this is a flat portion which we have got corresponding to this rectangular face which is appearing at the top of the solid over here. So this surface will be appearing like an edge view in the front view construction of the solid over there. And once we achieve the location of this particular point, so this is the location of point number 1 and point number 2 over here at the top surface, then we can obtain the inclined surface edge view in the front view. As we can observe that this inclined surface, it is going to start at a point 20 millimeter from the left hand side vertical edge of this particular solid, and from this point, that is at a height of 60 millimeter, this inclination is going to start, and this is going to end at the bottom point on the right hand side corner of this particular solid. So we can see over here, it is the bottom side, that is point number 7 and 8, they will be located over here. Point number 1 and 2, they will be located over here. So this way we have been able to complete one section of this particular front view. Now let us start with the second thing. So we know that the height of this whip, it is equal to 15 millimeter. So we know the height of the top web of the solid equal to 15 millimeter. So corresponding to this height, now a horizontal projection has been drawn. So we can see that this projection starts from this point, that is this point corresponds to this point in the isometric projection, and then from the front view we are going to obtain a horizontal line, and the length of this horizontal line, this will be obtained as per the construction in such a way that it will be terminating onto the edge view of this cut section over here in the front view. So in the front view, this is my edge view of the sectioned inclined cut section, and this particular lower portion of the web, it will be starting from this point, and this will be ending up at a point which is going to lie on to this edge view of the slant edge over here. So this point, that is point number 3, has been located over here. So point number 3, 4, 11 and 12. So 4 points, they will be lying at this particular intersection. So this distance is not available with us. So this is as per the construction that we can see in this particular orthographic projection. And having obtained this point, because this point we are going to need even in the top view. So in the top view also we are going to require this particular point number 3. So what we are going to do, we are going to take a projector vertical projector downward onto the top view projection over here, so that these points, they can be located even in the top view of this particular construction. So one part we have completed. Now another thing we know, the bottom web. The bottom web, again, it is going to have the height equal to 15 millimeter. So this is height equal to 15 millimeter. And then from this, as we are going to look at the solid from the front view, so we are going to get a horizontal edge over here, which is starting from the left extreme, and it is going to end up on a point which is going to lie onto the edge view of this inclined section surface over here. So this is my edge view of the inclined section surface. So starting from this point, I have drawn a horizontal line parallel to the XY reference line or parallel to the base of the solid, and this is the point of intersection. The moment I obtain this point of intersection, I am able to obtain points 6, 5, 10 and 9 over here. So these 4 points, they have been obtained over here. Now once I obtain these 4 points in the front view, now we are going to need these 4 points even in the top view. So we are going to project a vertical projector downwards over here. So with this, the construction of the front view has been completed. Now we are going to start with the construction of the top view of this particular solid. Now when we look at the solid from this side, now this is my top view. So we can check this rectangle over here. So this rectangle happens to be parallel to the horizontal plane. So in the top view, we are going to obtain the true shape of this rectangular surface. So we can check this is the rectangular surface which happens to be parallel to the horizontal plane, and this true shape has been obtained in the top view over here. Now after you obtain the true shape of this surface, now I have to work out the projections of this particular surface in the top view. So in order to obtain the projections of this particular surface in the top view, now we are going to make use of the dimensions over here. We know that the depth of this portion of the web, it is equal to 20 millimeter. Similarly, the depth of this portion of the web, it is also equal to 20 millimeter, and this will also be equal to 20 millimeter. So this is the depth of the solid. Now this depth of the solid, I need to divide into 3 parts. So we can check, this is the first element, that is 20 millimeter. So 20 millimeter from this edge. Now we have projected a distance of 20 millimeter over here, and the first horizontal line has been drawn over here in the top view. Similarly, from the bottom also, I mark a distance of 20 millimeter, and once this 20 millimeter distance location has been identified, so another horizontal line will be drawn over here. So this way I have been able to obtain the apparent shape of this inclined section surface over here in the top view. So this way, by marking these 2 depths over there as 20 millimeter, we can check this depth, it is 20 millimeter, this depth, it is also 20 millimeter. So in the top view, I had obtained these thicknesses over here from the front view projection. So this is the thickness of this particular inclined web. So this thickness of this particular inclined web has been projected corresponding to the points which we had obtained from the view. So this is one projection corresponding to this particular part of the web. Similarly, this part of the web, again, it has been obtained in the top view over here. So this part of the web in the top view has been obtained over here using the projections from the front view. So this thickness we have evaluated, this thickness also we have evaluated, and now this particular part we have evaluated from the projections of the top view over here, that is the width it was provided to us. Now let us darken the projections which are lying in the front view, and let us darken the projections of the edges which are available to us from the top view over here. So these are the projections corresponding to the edges which are visible to the observer while the observer is going to view the solid from the front. So we can check this portion, it is visible to the observer. So this has been drawn over here. Then the second portion, the vertical web and this inclined surface over here. So this is also visible to the observer. So this has been darkened. And the third portion, it is this web, bottom web over here. So bottom web, this portion is visible to the observer. So top web, bottom web, and then this vertical web which is inclined over here. Then looking from the top, this surface corresponds to this particular rectangle over here. Next, we have got the apparent shape of this particular inclined portion of the web. So this portion has been obtained using the information of the front view over here in the top view. Similarly, this portion. So this portion was obtained in the top view using the information from the dimensions which are available to us in the front view. And then this portion, we know this depth, it is equal to 20 millimeter. This depth, it is also 20. So the intermediate depth of this H-shaped web, it is also 20 over here. So this depth 20 we have marked over here. This depth 20 we had marked. Now this is our H-shaped surface for which we are required to evaluate the true shape. So in order to evaluate the true shape, we have already marked the different points which are appearing onto this section cut surface over here. And this section cut surface happens to be an inclined section cut surface. So these points now we are going to mark in the top view. So we can check. We are moving in a sequence. Point number 1, point number 2, point number 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Similarly, point number 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11 and 12. They have been marked over here. And as we discussed, there will be 4 points over here, 4 points over here, and 2 points on this side and 2 points on this side. So let us obtain the corresponding points in the front view. So as we are going to look the solid from this orientation, so we can see that in the front view, point number 2 and point number 1, they will be overlapping in the edge view. So these 2 points, they will be coinciding with each other and they will be marked as 2 dash and 1 dash over here. Over here, I am going to get the overlapping of points 3, 4, 11 and 12. So please check points 3, 4, 11 and 12. They will be appearing as an edge view as a point over here. So here we have 3 dash, 4 dash, 11 dash and 12 dash. Then as we are looking at the solid from this direction, what we get? 0.6, 5, 10 and 9. They are going to coincide. So points as we are looking from front side, 6, 5, 10 and 9. These points, they are going to coincide. And as they coincide, we get 6 dash, 5 dash, 10 dash, 9 dash in the front view projection. And finally, through this 7 and 8 points, so 7 dash and 8 dash points, they will be located along the edge view in the front view. So we can check as we are looking from this side, points 7 and 8, they will be coinciding over here. And once these points, they are coinciding, so we are able to get these 12 points along this particular edge view of the inclined cut section surface of the solid. Now having obtained the edge view of the inclined cut surface section of the solid, which is this one, now we need to evaluate the true shape of this section surface over here. So in order to evaluate the true shape of this sectioned inclined cut surface of the solid, we need to draw an auxiliary plane, which is auxiliary inclined plane, which is x1, y1, and this auxiliary inclined plane will be drawn parallel to the edge view of the cut section. So that is why we had chosen to draw the front view orthographic projections over here, because in the orthographic front view projections we have been able to obtain the edge view of this sectioned cut surface of the solid. Now, having obtained this edge view of the inclined cut surface section, now this AIP has been drawn parallel to this edge view. Now, from these 12 points, we have got 12 points alongside this particular edge view, so which are located as 4 points into this edge view. So from these 4 points, we are going to draw 4 projector lines which will be perpendicular to the auxiliary inclined plane x1, y1. So having drawn these 4 perpendicular projector lines over here, now we need to evaluate the distances of these points: point 1, point 2, point 3, point 4, point 5, point 6, point 7, point 8, then 9, and then 10, 11 and 12. So all these points, we are going to work out the distances of these points from the XY reference line, that is from the vertical plane. So we will be evaluating the distances of these 12 points from the vertical plane, and these distances will be marked alongside the corresponding projection lines which are corresponding to the different points which are appearing in the elevation. And once we plot the corresponding points onto the auxiliary plan view, we are going to obtain the true shape of this shaded portion over here. So this shaded portion is the apparent shape of this inclined cut surface section of the solid, right? So in order to obtain this particular true shape of the shaded portion, what we are going to do, first thing, we have got this particular top view drawn at a random or the arbitrary distance from the vertical plane. So this distance we did not mention while we were drawing the top view of the solid. So what we are going to do, so please check, we have marked this distance equal to distance x, and once we mark this distance equal to distance x, we are going to transfer the points 1, 12, 9 and 8 onto the corresponding projection lines in the auxiliary plan view. So let us mark this distance onto the auxiliary plan view. So this is the distance x which is corresponding to this distance over here. So this is a flexible distance, so this can vary depending upon the construction we are making. And once we have this distance available with us, we have marked this distance over here, and the projection line corresponding to this distance we have drawn over here. So we could have drawn a continuous line over here, but since we are required to obtain the locations of these points, so that is why only specific points we are going to mark over here. So this will be my location of the point 1, 1. This will be the location of point 12, 1. This will be giving me the location of the point 9, 1. And this will be my location of point 8, 1. And since these points, they are appearing corresponding to the projection lines which are visible to us from the elevation view. So we can mark these points 1, 1. So 1, 1 is located corresponding to the projection line of point 1 dash. 12, 1 point has been located corresponding to the projection line of the point 12 dash over here. Similarly, point 9, 1 has been located corresponding to the projection line where point 9 dash has been located over here. Similarly, 8, 1 point, it is lying on the projection line which is starting from the location point 8 dash over here. So the 4 points of this true shape we have been able to locate. Now the second thing we know, this distance, this is equal to 20 millimeter, right? So this distance is 20 millimeter ahead of the distance x. So the total distance of the points 11 and 10, they will be 20 millimeter plus x over here. So now once we have marked this distance as 20, so the total distance from AIP becomes 20 plus x. And once I mark this projection line, the points 11, 1 and 10, 1, they have been obtained over here. So again we can check 11, 1, it is appearing on the projection line which was initiating from the point 11 dash, and 10, 1 is obtained on the projection line where we had the location of the point 10 dash over here onto the edge view. So 6 points they have been located. Now once we know that the total depth of the solid, it happens to be 60 millimeter. So since the total depth is 60, so the distance 60 millimeter we are going to mark ahead of this distance x over here. So this was distance x. I have marked the distance 60 millimeter, and then the two ends I am going to locate over here. This is the first end and this is the second end. So here again 4 points we will be able to locate over here. Which are those points? These points are point 2, point 3, point 6 and point 7. So point 2 will be located over here, point 3, point 6 and point 7. So here we have got the points point 21, 31, 61 and 71. So point 21 is located on the projection line where the front view of the point 2 dash was located. 31 has been located on the projection line where the front view of the point 3 dash is located. Similarly 61, it is located where the front view of the point 6 dash has been located, and similarly 71 is located on the projection line where the front view corresponding to the point 7 dash has been observed over here in the edge view. So this way another 4 points they have been located, and we know that the distance of this edge from the front edge, so this is the front edge of the solid, right? So this is the front edge. So from the front edge, this distance happens to be 20 millimeter. So this distance we have marked as 20 over here. Similarly, this distance of 20 millimeter backwards we have marked from the front edge of this particular cut section. So once we move 20 millimeters back, now so this edge will be obtained over here, and we are going to locate another 2 points over here which will be points 4 and points 5. So this is point 41 and this is point 51. So 41 is also located on the projection line where the front view point 4 dash has been drawn over here. Similarly 51 has been located on the projection line where the front view of the point 5, that is 5 dash, has been located. So this is the true shape of the inclined cut section surface of the solid. So I can darken the edges which are visible to the observer, and since this auxiliary plan projection has been obtained by drawing an auxiliary inclined plane parallel to this edge view, so this is going to be the true shape of this inclined cut section surface of the solid. And now we can carry out the shading of this portion, and we can say that this is the auxiliary plan that we have developed onto the auxiliary inclined plane. So this is the procedure for obtaining the true shape of the inclined section surface which is lying on the top of the solid, which has been cut by an auxiliary inclined plane, right? So I hope that through this discussion you would have understood about the procedure to develop the true shape and size of the inclined section surface of the solid. So we'll be continuing with few more cases about the applications of the auxiliary planes in the coming lectures. So thank you very much. Thanks a lot.